Hello, algebra students. Today we're going to be going over the very first unit, the unit 1, and we're going to, in this video, go over the guided practice, which is in the front of the unit. Now, what I want you to do is just follow along the video, and as I go through the problems, I'm going to ask you to do some of the problems on your own, and I want you to just follow along and write down everything I write. And when I ask you to work on some of the problems on your own, simply pause the video, work on those problems, and then follow along again. I also want to point out that if you're having trouble with a certain concept or a certain problem, feel free to pause, rewind the video, and watch it again, see the example one more time. I also want to point out that if you need help besides the video, like if this video is just not enough help for you, you need additional support, you could always email me and we can set up an appointment to either meet virtually or you can meet at the center with me. My email is ttrigg@ofy.org. That's trig with 2 G's @ofy.org. All right. Well, with that being said, let's go ahead and go over the very first packet here and going over the guided practice. I'm going to share my screen, and you should see for your guided practice the very first page here. The first set of problems kind of look like this, and the first problem says, let me get my pen here. There we go. All right. The first problem says, how many times greater is 700 than 70? So here it's talking about how many times greater. So notice it says don't say 630, right? Because 630 would be how much greater, then you'd subtract. But when it says how many times greater, essentially what we're doing is we're dividing. So it'd be like 700 divided by 70. So 700 divided by 70, that's 10. Okay, and you could check with your calculator as well. Feel free to use your calculator throughout this entire course. Okay. How many times greater is 7,000 than 700? Well, that would also be 10. How many times greater is 70,000 than 7,000? Well, this would also be 10. So for the first 4 here, it's actually just 10. What about this one? From 7 million, how many times greater is 7 million than 700,000? 10. Okay, so kind of the pattern I want you to see is that notice that for the very first one, essentially what we're doing is we're doing 700 divided by 70. Okay, now notice that 700 just has one additional zero than 70, right? So when there's just one additional zero, that's the same as just multiplying by 10. So if you did 70 times 10, and you might notice that for times, I'm either using a dot or 2 numbers next to each other in parentheses. That's going to be pretty much how I'm going to show multiplication throughout. And you should get in the habit of doing that as well. But when you do any number times 10, you just add a 0. So 70 times 10 is 700. It just takes 70 and adds one more 0. Similarly, with the 7,000 is 10 times greater than 700, because if you take 700 and you just multiply by 10, that just adds one more 0. Here, again, adding just one more 0 from 7,000 to 70,000. So that's 70,000 is 10 times greater here as well. Okay, so 7,000 times 10 just adds another 0. Here, you're just adding another 0, that's times 10. Here, adding another 0 times 10. Well, from 7 million to 70 million, how many times greater is 70 million? Well, it's just adding one 0, isn't it? So that would be 10 here as well. From 70 million to 700 million, same thing. You're just adding one 0. And from 700 million to 7 billion, here this 700 million has 8 zeros. And 7 billion has 9 zeros, so that's just adding one more 0. In other words, 7 billion is 10 times bigger than 700 million. And that's kind of the case because we're in a base 10 system, right? We count by tens and so forth. Now let's take a look at number 9 here. It says how many times bigger is 5,000 than 50? So in this case, from 50 to 5,000, we're not adding just one zero, but we're adding two zeros, aren't we? Right? So 50, you'd have to add two zeros to get to 5,000. So how many times greater? It's actually going to be 100 times greater. 100 times greater. Okay? So the number of zeros basically tells you the number of zeros that is the difference here, tells you the number of zeros need to be multiplied by, essentially. Okay? So see if you can answer these on your own. All right? So how many times greater is 1,000 than 100? How many times greater is 10,000 than 100? So just think how many zeros are added, right? Here, I'll go ahead and do this one with you. Here, how many times greater is 1,000,000 than 1,000? Well, how many more zeros are there? There's 3 more zeros, aren't there, right? 1,000 has 3 zeros, but 1,000,000 has 6 zeros. So you need to add 3 more zeros. So 1,000,000 is adding 3 zeros 1,000 times bigger. And you could always check with your calculator. 1,000 times 1,000 should give you 1,000,000. Similarly here, see if you could figure this one out. Okay, how many times greater is 1,000,000,000,000 than 1,000,000,000? Okay, so figure out how many zeros are added there. And that'll tell you what to multiply by. Same thing here. So how many times greater is 1,000,000,000,000 than 1,000,000? So 1,000,000 has 6 zeros, while 1,000,000,000,000 has 12 zeros. So we needed to add, how many more zeros do we need to add? From 6 zeros to 12 zeros, we need to add 6 more zeros. And again, you could always check with your calculator. 1,000,000 times 1,000,000 should give you 1,000,000,000,000. All right. How many times bigger is 10 to the 24th? And you could see what this number looks like expanded. It's 1 with 24 zeros, which is, I guess, the number of water molecules in a glass of water. How many times greater is that than 10 to the 12th, or in other words, 1,000,000,000,000? So 1,000,000,000,000 has 12 zeros, and this number here, 10 to the 24, has 24 zeros. So if I went from 12 zeros to 24 zeros, I would have to add 12 more zeros. So 1, and we're going to put 12 zeros. 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Okay. All right. These are kind of the same problem, right? So 200 times what gives me 2,000? So how many zeros do I need to add? Well, 200 has 2 zeros, 2,000 has 3, so I need to just add 1 more zero, so times 10. And again, you could always check with your calculator. 200 times 10 should give you 2,000. Okay, see if you could do number 2, number 3 on your own. Now next here, we're dividing. Well, this is kind of similar, right? So when you multiply by 10, as we've shown with this problem and the problems above it, when you multiply by 10, you just add a 0. Well, what about when you divide by 10? Well, when you divide by 10, you take away a 0. Okay, so 300,000 divided by 10 is going to be 30,000. Okay, so this had 5 zeros here, but then we take away a 0 because we're dividing by 10. That gives you 30,000. So 4 zeros. Okay, see if you can do number 5 and number 6 on your own. Again, number 7, again, when multiplying by 10, we add a 0. So 400 times 10, that would be 4,000. Here, 400 times 100, well, 4 times 1, that's 4. And then we'd add 1, 2, 3, 4 zeros. 1, 2, 3, 4 zeros. Okay, so this would be 40,000. Okay, you should be able to do these all in your head, but you could always check with your calculator. Here, 400 times 1,000. 4 times 1 is 4. So I'm multiplying that front number, right? And then I'm adding however many zeros are at the end here. So 2, 3, 4, 5 zeros. 1, 2, 3, 4, 5 zeros. So however many zeros are here, that's what we're going to add to the end of that. Okay. So this one's, let's see this one here. So 5 times 4, that's 20. Okay. So this zero came out comes because the 4 times 5, right? 5 times 4. And then we need to add 1, 2, 3 more zeros. 1, 2, 3 more zeros. 2 here, 1 here. So that's 3 more zeros. 5 times 4, and then put 3 more zeros at the end of that. Okay. Similarly, this one, 5 times 4, that's 20. And then how many zeros do you suppose we're going to put at the end of that? Well, 4 more. 1, 2, 3, 4 more. 1, 2, 3, 4 more. So 200,000 is this answer. Okay, see if you can do number 12 on your own. Okay, number 13. So for these ones, whenever there's like zeros above each other, now this really only works with zeros essentially, but you can cancel these out. So essentially every time you're canceling out zeros, you're essentially reducing by 10, right? Divide by 10, that cancels these zeros. You're reducing the fraction, right? And then we just have 8 divided by 4, which is 2. Okay. And again, you could always check with your calculator. You could try 80,000 divided by 40,000. You will get 2. All right, number 14 here. Again, I can cancel out, in this case, I can cancel out 3 of these zeros with each other. Now it's 80 divided by 4. Well, I could kind of just think about it with 8 divided by 4, which is 2, and then just add that 0 at the end, so 20. Okay, 8 divided by 4 is the 2, and then there's a 0 on top there. See if you do number 15 on your own. Now, what about numbers that have a decimal point? So in this case, number 16, it says 25.622. Well, the first thing I want to talk about is what a decimal point means. I'm sure you've seen them before throughout your career through math, but perhaps the most obvious place we see decimals is in money. So when I say like 5.35, and if I'm talking about money, you know that this represents $5.35. Essentially, the decimal's job here is to separate the whole dollars from the partial dollars, right? Separates the whole from the part. So there's 5 whole dollars, and then there's like a portion of a dollar after the decimal. And that's basically a decimal's job. It separates whole numbers from like a fractional number. A very common decimal you'll see a lot, and you kind of have to know what it means, is 0.5. So if I say, for example, 6.5, what this actually is the same as is 6 1/2. So 0.5 is the same as 1/2. So whenever you see 6.5 or 10.5 or anything 0.5, know that that's that many holes and then a half. Okay, you'll see that very commonly. Don't worry about memorizing it. You'll kind of just see it often enough that you'll begin you'll just know it. Okay. Now, when we multiply a decimal by a power of 10, what that does is it moves the decimal however many places. So in this case, times 10, well, that's going to make it bigger, isn't it? Right? When we multiply by 10, that makes the number bigger. So that moves the decimal to the right. Okay, so this 25 point something now becomes 256.22. Okay, so times 10, we move the decimal to the right once. What about times 100? Well, how many places do you suppose we move the decimal? In this case, we're going to move the decimal twice. Basically, you move it for every 0 there is, you're going to move the decimal one more spot. So times 100, we're going to move it over 2 spots. So this is going to become 2 5, 6, 2, then the decimal 2. Okay. What about dividing by 10? Well, dividing by 10, this will make it smaller, right? When you divide by 10, that makes a number smaller. So we're going to actually move the decimal to the left in this case. So dividing by 10 is going to make this number 2.5622. All right. And again, you could always check with your calculator. Let's try these. So here, 220 times 30. So now hopefully you'll be able to do this in your head. But what we can do is just take the 22 times 3. So 22 times 3, that's 66. And then add how many zeros? 1, 2 zeros. 1, 2. Similarly, 50 times 20, we multiply the 5 times the 2. That's 10. And then we add 1, 2 more zeros. 1, 2 more zeros. Okay. See if you do number 21 on your own. Okay. Now we're on page 8 here. There are approximately 330 million people that live in the United States. There are approximately 33 million people that live in California. How many times bigger is the population of the United States than the population of California? So how many times bigger, right? So essentially what we would be doing is dividing, but we could just see, well, we can cancel out those zeros, right? Or in other words, the population of the United States only has one additional zero over the population of California. So that would just be times 10 because you're just adding one more zero. It is approximately 1 million miles, or 100 million miles from Earth to the Sun. It is approximately 200,000 miles from the Earth to the Moon. Approximately how much farther is it from the Earth to the Sun than from the Earth to the Moon? So again, we're dividing here. So 100 million, so that's a 1 with 8 zeros, divided by 200,000, so that's a 2 with 5 zeros. Now again, when you see zeros over zeros, you could always cancel out some of these zeros. So I can cancel out 5 of these with 5 of these. So I'm left with this 1,000 divided by 2. Well, what's 1,000 divided by 2? Well, that's 500. Okay. See if you could do number 3 on your own. I think 3, 4, 5, and 6. I'm going to let you try those on your own. Again, just multiply the front numbers and then add all of those zeros. So in this case, you would add 12 zeros at the end, 6, and then 6 more. Okay. Same thing here. So for example, 250 times 10. Well, what does times 10 do? It just adds additional 0, right? Times 100 adds 2 additional zeros. So see if you could do these. Here, this times 10. Now we're dealing with a decimal. If you remember, that moves the decimal to the right once. So this would be 2,563.5. So that moves it over here. So in terms of money, that's $2,563 and a half a dollar, right? So 50 cents. You can put a 0 there if you want. Divided by 100, remember that moves the decimal to the left. So see if you can do that one. For this one, dividing here, oh, there's 6 zeros down here and 6 zeros up here. We can cancel those. Now I just have 90 divided by 3. Well, 9 divided by 3 is 3, and then just put an extra 0, 30. Let's talk a little bit more about fractions. Basically, a fraction, as you may already know, is a number that's not quite a whole number, right? It's less than 1. A fraction is more than nothing, but less than 1, right? Half of a cookie is more than nothing, but it's less than having a whole cookie, right? Now, all these fractions here are actually equal. They're all equal to 1/2. right? 1 divided by 2 is the same as saying 5 divided by 10 or 12 divided by 24. Notice that 1 is half of 2. 5 is half of 10. 12 is half of 24, and so on. So all of these fractions are all equal to each other. They're all equal to each other. They're all equal to 1/2, or in other words, 0.5. These are all equal. And you could always check with your calculator once again. If I did 1 divided by 2 in my calculator, 1 divided by 2, I get 0.5. If I did 5 divided by 10, I also get 0.5. Or 100 divided by 200 also gives me 0.5. Okay? So let's talk about greater or less in the space provided. So for each of these problems, write the word greater or less in the space provided. So here we have 31 over 60 is blank then 1/2. So we want to figure out 31 out of 60. Is that greater than 1/2 or is that less than 1/2? Well, if we think about 1/2, isn't that equal to, well, how many out of 60? So 1/2, if I change the denominator to 60, how many is half of 60? Well, wouldn't that be 30? So 30 out of 60 is 1/2, isn't it? Right? 30 is half of 60. Well, 31 out of 60 must be more than 30, right? So this is actually greater than. Okay. I would also encourage you not just to write greater, so that's great, but also I want you to use the greater than symbol. So you get the hang of using these as well. Okay. If you remember, this one was greater than, and then, so this one is greater than. And the other one is less than. Okay. So I would suggest that you get the hang of using these as well. They're going to continue to be part of your math journey throughout this class. So we already talked about 30 out of 60 is 1/2. So 25 out of 60, well, that must be less than 1/2, isn't it? Or in other words, put that. Okay. What about 1/2 compared to out of 20? So if I did 1/2, that's equal to how many out of 20? So what would this numerator be in this fraction if I want it equal to 1/2? So what's half of 20? Well, 10. So you can think of it like getting questions right on a test, for example, right? If you got 10 out of 20, you've gotten half of them right? So 10 out of 20 would give you half. All right, well, then 12 out of 20 is, well, that's greater than that, isn't it? So this is going to be a greater than. What about 9 out of 20? You should be able to answer that on your own. Next, let's talk about with the denominator of 10. So if I have 1/2, that would be how many out of 10? So what would this numerator be here? So see if you can figure that out, and then see if you can do numbers 5 and 6 on your own. What about this one? So 1/2, that's, if I change the denominator to 400, what would be half of 400? Well, hopefully you can see that that's 200, right? So 200 out of 400, that's the same as half. So 198 out of 400, well, that's less than this, right? So that's less. Okay. Now, I do want to kind of talk about, don't be confused just because these numbers here in this fraction, right? These numbers are bigger, right? But that doesn't mean the fraction is bigger. Okay. So getting half of the questions right is actually more than getting 198 out of 400 right. Okay. I'd rather have half of a cookie than 198 out of 400 of a cookie, if that makes sense. Okay. So we're going to talk more about how to convert your fractions here. So one thing you can kind of look at when I'm looking at a fraction, I'm figuring out, okay, well, I have 4 out of 5, but let's say I want to make it a fraction that has 10 as its denominator. Well, the way you would do that is you would look, well, I've got 5 as my original denominator here. So what do I need to multiply by to get to 10? So 5 times what would give me 10? So hopefully you'd see, okay, well, that's times 2. Again, I'm using a dot for multiplication. You're going to see that a lot. Or you might see just parentheses as a number up against a parentheses like that. That also means multiplication. Okay, you're not going to see an x as multiplication very often anymore. Okay, just so you know. So anyway, 5 times 2 gives me 10. All right, well, if I multiply the bottom by 2 to get 10, that means I need to multiply the top by 2 to figure out my new numerator. So 4 times 2, that gives me 8. So in other words, 4 out of 5 is the same as saying 8 out of 10. Those two fractions are equal. And again, you could always check with your calculator. So if I did 4 divided by 5, I get 0.8. If I do 8 divided by 10, I also get 0.8. Okay, so they should give you the same decimal. That's how you could always check to make sure the two fractions are equal. They should give you the same decimal. Okay. And since we're on the topic of decimals and how to change it to fraction, these are equal here. Okay, and I want you to put equal signs here. Okay, and in fact, these are all equal to each other. I want you to take a moment to look at that, see if that makes sense. So if you got 8 out of 10 on a test, 8 out of 10 correct, that would be 0.8. If you got 80 out of 100, that's also 0.8. 800 out of 1,000 is also 0.8. Okay. It might not be that obvious, but you can maybe perhaps check like, oh, you see how there's a 0 here? You could always cross off on that 0 and notice it gives you back to that fraction here. Right here, you can cross off 2 zeros and it gets you back to that fraction here. But it's just kind of showing that there are multiple ways to write it as a decimal and multiple ways to write it as a fraction. Okay. Let's go on to this example here. So here I've got 3 out of 4. Okay. And I want to make it out of 100. So I want to figure out 3 out of 4. How do I make the denominator out of 100? Well, what would I multiply by to get to 100? So 4 times what would give me 100? Well, it'd actually be 4 times 25. So 4 times 25, that gives me 100. Well, if I multiply the denominator by 25, I have to multiply the numerator by 25 as well. So 3 times 25, and you can use your calculator there, that gives you 75. And again, you could always check with your calculator. 3 divided by 4 should give you the same decimal as 75 divided by 100. In fact, they both give you 0.75. Okay. So let's go ahead and work on these. So 4 out of 5. If I want to make the denominator 10, I would have to multiply by 2. 5 times 2 to get 10. So I multiply top times 2. That's 8 out of 10. If I want to make it out of 100, 5 times what gives me 100? Well, it's 5 times 20 to get 100. And 4 times 20 to get the new numerator. This would be 80. Let me go ahead and pause the video. There's a leaf blower going on. Okay, and we're back. Let's take a look at how we do these. So again, I just wanted to emphasize that when we're changing a fraction to a different denominator, we need to find what to multiply by. In this case, if we're changing to 100, 5 times 20 gives you 100. So then you would do 4 times 20 to get the new numerator as well. Whatever you multiply the bottom of the fraction, you multiply the same thing on top. So that'll give us 80 out of 100. Now, if you want to change that to a decimal, you could simply divide with your calculator, but it's actually pretty easy because it says 80 100ths, right? So as a decimal, that's just like this, 0.80. So this is 80, and the second decimal place is what we call the hundredths. So the first decimal place is called the tenths. The second decimal place is called the hundredths. So 80 100ths can be rewritten like this. If you want to put a 0 in front of the decimal, that's fine, right? That's the same as saying like $0.80. You don't need to put the $0, but it's not wrong if you do. You'll see it both with the 0 and without the 0, so that's fine. Now, to change it to a percentage, well, when you have it out of 100, it's already telling you the percentage. So in this case, 80 out of 100, that's 80%. And that's the percentage. Is that less than 1/2 or is that greater than 1/2? Well, 80%. If you know percentages, you know that 1/2 is the same as 50%. Okay, so 1/2 is the same as 50%. So 80% is certainly more than 50%. So this is greater than. One-half. Or you could put greater than, that's less than. You could also say greater than 1/2, like this. Okay. What about 1/4? Well, to go from 4 to 100, you'd actually have to multiply by 25. So 4 times 25 gives you 100. So if I multiply the denominator by 25, you need to multiply the numerator also by 25. So that would give you 25 hundredths. As a decimal, that's 0.25. As a percentage, that's 25%. And you can tell me whether that's greater than 1/2 or less than 1/2. I want you to try this next one on your own. Notice it's a 4 on the bottom, same as what we did here. So what do we need to multiply to get to 100? Okay, see if you can finish the rest of that row. What about this one? If I want to go from 50 to 100, I would have to multiply by 2. 50 times 2 is 100. So here I'd multiply the numerator also by 2. So that would give you 44 out of 100. See if you could write it as a decimal, then as a percent, and then tell me if it's greater than or less than 1/2. Here, 50 times what to get 100? So this would be times 2 again. See if you can finish this row. It's very similar to the one we just did above. 20 times what gives me 100? 20 times 5 gives you 100. So you'd multiply the numerator also by 5, getting us 80 out of 100. See if you can finish it from there. Okay. Now, if you get 10 out of 10 correct on a test, you scored 100%, right? Because you got all of them right. If you got 10 out of 10, that's 100% on your test. So 10 out of 10 as a fraction, that's 10 over 10. Well, that's the same as saying 10 divided by 10, isn't it? When you think about a fraction, that's the same as saying division, 10 divided by 10. So 10 divided by 10, that's 1. So 10 out of 10 is both 100%, but it's also 1. So in other words, 100% is 1. So 10 out of 10 is 1. What about 20 out of 10? Well, that's 2. What about 30 out of 10? Well, that's 3, right? You could always think of it as division as well. 20 divided by 10 is 2. 30 divided by 10 is 3. How would you write 34 out of 10 as a percent? So you can make it out of 100, right? So 34 out of 10. If I want to make this into a fraction with 100 as the denominator, we'd have to do 10 times 10 to get 100. So you multiply the numerator also by 10, and that'll give us 340 out of 100. And to change that as a percentage, that's whatever number is above 100 here, that tells you the percentage. So that's 340%. Notice this is more than 100%, right? 100 out of 100 would be 100%. So 340 out of 100 is 340%. Okay. You could also write it as 3.4 if you wrote it as a decimal, or 3.40 similarly. Okay. These are all very similar to what we did before, but these ones all have answers that are greater than 1, right? Because notice the numerator for this example here, the numerator is greater than the denominator. So this will have a value greater than 1. But you do it very similarly. So 5 times what to get 10? Well, 5 times 2 to get 10. So you multiply the numerator also by 2. That gives me 42 out of 10. To change this to a decimal, this would be 4.2. Now to go from decimal to percent, one very easy way you can do it is just move the decimal 2 places to the right. And you can see this in the example. 2.4, if we change that to a percentage, you'd move it over twice. That's 240%, right? So, and that's how they got that. Similarly here, we can move the decimal twice. This would be 420%, which would be 4 wholes, right? And you could always check too. You could always divide this in your calculator. 42 divided by 10 will give you 4.2. What about this one? So 20 times what to get 100? Well, 20 times 5 to get 100. I multiply the numerator also by 5. Let's see what that is. 62 times 5, 310. So it's 310 out of 100. So what would that be as a decimal? Well, that would be 3.1. Move the decimal over twice to get a percentage, 310%, which is 3 wholes. Okay. For this one, 4 times what gives me 100? Well, 4 times 25. I multiply the numerator also by 25, which is 425. See if you could finish the rest on your own. Here, 50 times 2 gives me 100. I multiply the numerator also by 2. Whatever you do, multiply the denominator by, you multiply the numerator by the same. So this would be 202 out of 100. See if you could finish the rest. Okay. Now let's talk about how to find a percentage of a number. So this example here asks, what's 20% of 400? 20% of 400. Well, the simplest way you could do that is simply change the percentage to a decimal. So if I want to do 20%, you move the percentage over twice, and that changes it to a decimal. So this is equal to 0.20, moving the percentage over twice. Then you multiply this 0.20 times 400 with your calculator, and in this case, that gives you 80. So what's 20% of 400? Well, that's 80. Okay. Now, there's also a very fast way we can do it as long as we know 10%. Now, 10% is actually a very easy percentage to calculate. So if you ever want to find 10% of a number, all you need to do is move the decimal 1 place. So for example, they give 10% of 400. So 10% of 400. That's the same as asking 10% times 400. So you could always just change this to a decimal and multiply by 400. But what that does is essentially the decimal at the end of 400 is right here. When you're taking 10% of it, you move the decimal over just one place. So 10% of 400 is 40. Well, if 10% of 400 is 40, then what would be 20% of 400? Well, if we know 10% is 40, 20% is twice as much, right? So this would be 80. Right, so that's a fast way you can do it as well. So it just kind of showed you two different ways to find 20% of 400. You can simply change the 20% to a decimal and multiply by 400. Or you can go with trying to do it in your head. You know 10% is 40, so 20% is twice as much. That's 80. So here, let's try a little more mental math here. So 10% of 6,000 is 600. Again, just it crosses off 1 0, or in other words, moves the decimal one place. Then 20% of 6,000 will be double that. So double 600, that's 1,200. If 10% of 5 million is 500,000, then 5% of 5 million, well, if 10% is 500,000, 5% is half of that. So this would be 250,000, right? If 10% is 500,000, then 5% is half of that. So half of this. To find 1%, you could do that quickly. Basically, you just move the decimal two places. So this example, 1% of 7,000 is 70. 1% of 95,000 is 950, moving two decimal places. Whenever you have a whole number, you know the decimal is at the end. So that moves it over two places like that. If 1% of 7,000 is 70, then 2% will be double that. So this would be 140. If 1% of 5,000 is 50, then 3% will be 3 times that, right? So 3 times 50, that's 150. So it's kind of how you can calculate a lot of percentages in your head. Number 6. Let's try a little bit more of a brain teaser. What is 11% of 4,000? All right, so there's a couple ways you could do it. You could simply change 11% into a decimal. That would be 0.11. And then just multiply by 4,000. So that's one way. You can do it with a calculator. Not too bad. But we could also do this in our head. So the first thing I'd want to find is what's 10% of 4,000? So to find 10%, again, you just take off 1 0, or in other words, move the decimal one place. So 10% of 4,000 is 400. And what about 1% of 4,000? In that case, you would take off 2 zeros, or in other words, move the decimal two places. So that would be 40. So 11% would be 10% plus the 1%. That would make 11%. So 400 plus 40 is 440. So 11% of 4,000 is 440. Okay. And they show you that example there too. 10% of 4,000 is 400. 1% of 4,000 is 40. So 11% is the 10% plus the 1%. So that's 440. Okay. So now let's try to do some mental math here. So for example, they give you this example of 200. To find 10%, you just move one decimal. To find 20%, that's double the 10%. 30% is triple the 10%, right? So in other words, to find this one, you just remove 1 0, or in other words, move the decimal one place. Here, to find this one, you would do the 10% times 2 to find the 20%. For 30%, you would do the 10% times 3 to find the 30%. For the 5%, you would take the 10% and then you'd cut it in half, or in other words, times 1/2, or in other words, divide it by 2, right? So 20% divided by 2 gives you 10. Just as the 10% divided by 2 gives you 5%. To find the 1%, you move the decimal 2 places. Here, I'll just show this one decimal place. Here you do 2 decimal places. To find the 2%, you would do the 1% and then multiply by 2. To find the 11%, you would do the 10% plus the 1% to get 11%. Okay, and I'll kind of show you as we go. So, for example, 10% of 700, we move the decimal 1 spot, so that makes 70. To find 20%, I simply double the 10%, right? The 10% answer times 2. So that would be 140. To find the 30%, we take the 10% times 3, so that's 210. So 30% of 700 is 210. 5% of 700, well, we can just take the 10% and then cut it in half. So that's 35. So half of 70 is 35. Now, what about the 1%? Well, for the 1%, we move the decimal 2 places. So that's 7. Okay, 7 is 1% of 700. To find the 2%, we double that. So that's 14. And to find the 11%, we take the 1% and the 10% and add those together. So the 1% plus the 10%, so that's 77, adding those together. Okay, see if you can do this next one on your own. So here, I want you to try do this one on your own, do this one on your own, do this one on your own, and I'll help you with this one here. So 10%, we move the decimal 1 spot, so that's going to make 8. For 20%, we double that, so that's 16. For 30%, we triple the 10%, so the 10% times 3. So that makes 24. For the 5%, we cut the 10% in half. So that's 4. Cutting this in half. For the 1%, we move the decimal 2 places. So this is actually 0.8. Okay, so 1% of 80 is 0.8. For the 2%, we double the 1%. So that's 1.6. In other words, the 0.8 plus another 0.8. Or another way of thinking of it is 0.8 times 2 gives you the 2%. Okay. For the 11%, we add the 10% plus the 1%, so that's 8.8. Adding this 8 plus this 0.8 is 8.8. Let's try this one. This one's with money, but it's the same deal. If I want to find 10%, we move the decimal 1 spot. So that's going to become 35.27. So that's the 10%. To find the 20%, we simply multiply that by 2. I'm just going to use a calculator. So that's 70.54. So $70.54. For the 30%, we take the 10% times 3. 35.27 times 3, which is 105.81. For the next one, the 5%, we take the 10% and divide by 2. So that's just 35.27 divided by 2. So that's going to be 17.635. So this is the 5%. For the 1%, we move the decimal 2 places. So that's going to become 3.527. That's the 1%. For the 2%, we double that. So 3.527 times 2 is 7.054. And lastly, for the 11%, we add the 10% plus the 1%. So 35.27 plus 3.527. 38.797. Now, one more thing I want to point out is that you could have always done these by changing the decimal changing the percentage to a decimal and then just multiplying, right? So as 10% as a decimal, you'd move the percentage over twice. That's 0.10. For 20%, that'd be 0.20. And simply multiply that by 200, you should get 20. Multiply this times 200, you'll get 40, and so on. Change this to a decimal, that's 0.30. What would this be as a decimal? Well, we'd move the percentage over 2 times, so that's 0.05, okay? So moving over once, twice, 0.05. Here would be 0.12, 0.01. Here, 0.02, and here, 0.11. So you could just multiply this, your total, times each of these to get what's in each of these boxes. Okay, so 200 times 0.11, for example, will give you 22. And you could just check that with your calculator. So that's one way you could always check your work as well. Okay. Okay, now let's move on to page 20 here. And these are basically all ways of saying the same thing. So when it says what's 10% of 80, well, we already know how to do that. We know a couple ways to do that. We could change this 10% to a decimal, making it 0.10 and multiplying by 80, and this will give you 8. Another way you could do it is to just find 10%. You just move the decimal one spot, so that makes 8. That's the same, 10% of 80 is the same as asking what's 10% times 80. Those are the same question, which is the same as saying 0.10 times 80, right? Because 10% as a decimal is just 0.10. This 0 at the end doesn't really add anything, so that's also the same question. You could also look at it like this or like this. So 10% is 10 out of 100. That's 10%. Multiply by 80. When you multiply fractions, you multiply top times top, bottom times the bottom, and divide. So these are all ways saying the same thing. Okay. See if you can do this one on your own. So find 20% of 300, and all of these will actually be the same answer. Okay. So these are all ways of looking at the same question. Okay. See if you can do the rest of these on your own. All right. Next, page 21. Mike got 3 out of 5 questions on his quiz correct. So that's 3 out of 5. How would you write 3 out of 5 as a decimal? The wrong answer is 3.5. That is wrong. Okay, so don't do that. To write a fraction as a decimal, it's actually pretty easy. All you need to do is divide. So it's 3 divided by 5. And you could always do that with your calculator. 3 divided by 5, and you should get 0.6. So as a decimal, it's 0.6. What would that be as a percentage? Well, to change from decimal to percentage, we move the decimal to the right 2 places. So that's the same as saying 60%. Okay, so he got 3 out of 5, which is a 60% on his test. What about 2 out of 5? See if you can do that on your own. You could always use your calculator. 2 divided by 5, get the decimal. Change the decimal to a percentage. Same here. 14 divided by 20. This should give you 70, I believe. Yeah. So this gives you 0.7. Change that to a percentage. Move it over twice, right? What is 20% of 3,000? Well, you could always change the percentage to a decimal and then just multiply. So that would be 0.20 times 3,000. And that'll give you your answer. What is 5% of 3,000? Again, we could just change the the percentage to a decimal by moving the percentage twice to the left. So that's 0.05, right? Moving it over twice, times 3,000. Okay. To find 1%, see if you can do that. To find 11%, see if you can do that. I do want to point out one fact about this one here. I want to point out the fact that 0.5, a lot of people would change 5% and just say 0.5. That is wrong. Don't do that. 5% is not 0.5, okay? Actually, 0.5 is the same as saying 50%, okay? So, and you can see that if I move the percentage twice, that gives me 0.5. So 0.5 is the same as 50%, whereas 0.05 is 5%. Okay, these are very different amounts. But if you always remember, you move the decimal, or sorry, the percentage twice to make and put it as a decimal, you'll always get it correct. So just make sure that you get that right. Okay, big difference there. How big of a difference? Well, think of it like money, right? So 0.5 would be like 50 cents, right? Whereas 0.05 would be 5 cents. Okay, big difference. All right. Page 22. Students often confuse the greatest common factor with the lowest common denominator. They are both useful concepts, but they are not the same thing. Let's start with the greatest common factor, the GCF. Take a look at the numbers below. 6, 9, 12. Can you think of a number that 6, 9, and 12 are all divisible by? That is, what number can you divide 6, 9, and 12 all by? So I'm looking for a number that I can divide all three of these by. So let's think about what I can divide 6 by, right? I can divide it by 6. I can divide it by 2, and I can divide it by 3, and I can divide it by 1. What about 9? Well, I could divide 9 by 9, and I could divide it by 3, and I could divide it by 1, right? So if I divide it by each of these, it would come out to a whole number, right? 9 divided by 9 is 1, 9 divided by 3 is 3, 9 divided by 1 is 9, right? So 9 is divisible by these three factors here. What about 12? 12 is divisible by 12, and also 6, and also 4, 3, 2, and 1. 12 has a lot of factors. So now we want to look at what's the greatest common factor. So I'm looking for a factor that they have in common, right? And I want the biggest one. So you might notice, oh, they all have 1 in common. Well, that's true, but it's not the greatest common factor. The greatest common factor is 3. They are all divisible by 3. So in this case, the greatest common factor is 3. So let's move on a little bit. So what about when I have, let's say, I ask for what's the greatest common factor between 80 and 10? Well, one thing to look at is I noticed that, well, 10 is divisible by 10, right? 10 is divisible by 10. So that's so 10's greatest factor is 10, right? It has other factors like 2 and 5, but 10 is its greatest factor. Well, 10 also divides 80, right? So 10 is a factor of 80. So the greatest common factor is automatically 10 because 10 is 10's biggest factor, and it's also a factor of 80. So that must mean that it's the greatest common factor. All right. Now, when you're multiplying fractions, one thing you can do is you can reduce the fractions before multiplying. And a lot of times that helps a lot. So what I would look for is, well, let's look at this fraction here, 6 over 9. I can reduce that fraction, can't I, right? I can divide both of these by 3, reducing the fraction. So dividing both top and bottom by 3, that gives me 2/3 for this fraction, 2 over 3. And I can reduce this fraction as well, dividing both top and bottom by 3 here, right? This is divisible by 3, and 12 is divisible by 3. So dividing both top and bottom by 3, that's 1 out of 4. Okay, so now that makes a simpler problem, but we could also reduce diagonally. So you can do what's called cross-canceling, where you can reduce the numerator of one fraction with the denominator of another. Now, this is only when you're multiplying. So you can only do this when multiplying. You can cross-cancel, or in other words, reduce diagonally. So notice the 2 and the 4. I can divide both those by 2. So that'll make this one a 1. And this one divided by 2 is 2. Now when I multiply the fractions, all you need to do is multiply top times top, 1 times 1, and bottom times bottom, 3 times 2, which is 6. So 1/6 is the answer to this multiplication. Now let's talk about lowest common denominator. So for lowest common denominator, what you want to look for is the multiples of these numbers. So for example, the multiples of 6 are 6, 12, 18, 24, 30, and it keeps on going, but I'm going to stop there for now. Maybe I'll have to add more to this list if I don't see a common multiple, right? So when you're looking for lowest common denominator, you're looking for the lowest common multiple, essentially, right? So you're looking at the multiples of those numbers. So these are the multiples of 6. So for 6, these are its multiples. What about for 9? What are its multiples? So 9, 18, 27, 36. Sorry, I couldn't think there for a second. 45. Okay, we'll stop there. But the multiples go on forever, right? But we'll just stop there for now. We might have to add more to this list later. For 12, we got 12, 24, 36, 48, 60. Okay, let's stop there. Now, do I have a common multiple yet? Do I see a multiple that are in all 3 lists? Well, there's some numbers that are close, right? Like 12 is in the first list and it's in this list as well, but it's not in my 9s list. So, or like 18 is in the 6s list and in the 9s list, but it's not in the 12s list. Okay. So usually if I don't see a common multiple yet, what I'll do is start expanding the shortest list. So in this case, the 6 only goes up to 30. So I'm going to continue to expand that. So 36. Oh, and I could actually stop there because 36 is in all 3 lists, right? Okay. So in this case, our lowest common denominator is 36. Now, what does that mean? That means whenever you want to add fractions or subtract fractions, you're going to need to find the lowest common denominator. So if these are my denominators of a fraction, let's say I've got 1/6 plus 1/9 plus 1/12, and these are my denominators, I would have to change the denominators to have a matching denominator. In other words, I'd have to change them to 36 in this case. And when I do that, then I'd be able to add or subtract the fractions together because you can only add or subtract fractions when they have the same denominator. Okay, so let's look at some examples here. So here you want to find the greatest common factor and the lowest common denominator of these lists. So what I would do is just try to find all the greatest common factors, then find the lowest common denominators. Okay. So the greatest common factor between 10 and 15, I'm looking for a number that divides both of these. So in this case, that's 5. 5 divides 10, 5 divides 15. So 5 is the greatest common factor. It's a factor of both of these. What's a common factor between 6 and 8? Well, that's 2. What about for this group? 7, 14, 28. Well, in this case, it's actually 7. 7 divides 7. 7 divides 14. 7 also divides 28. So 7 is the greatest common factor here. For this list, 10, 20, and 25, we're looking for a number that divides all 3 of these. That would be 5. What about this list? This one would be 3. So 3 divides 3, 3 divides 6, 3 divides all of these. What about the lowest common denominator? Okay, so here you might have to make a list, right, of the multiples of 10 and the multiples of 15, for example. 10, 20, 30. 15. 15 times 2 is 30. Okay, I've got one in common. So 30 is my lowest common denominator for 10 and 15. Okay. See if you can do this 6 and 8. See if you can find the lowest common denominator here. For this list of three numbers, it's actually going to be 28. Okay, 28 will be in all three of their lists. 28 is a multiple of 28. 28 is a multiple of 14. And 28 is a multiple of 7. For this next list here, what would this one be? Well, this one would actually be 100. Okay, lowest common denominator for these three numbers is 100. And for this last list, let me think. I think it's just 36. Yeah, 36. 36 is a multiple of all of these numbers. 18 times 2 makes 36. 12 times 3 makes 36. 9 times 4 makes 36. 6 times 6 gives you 36. And 3 times 12 gives you 36. Okay. So now let's go over how to multiply and add or subtract fractions. So we're going to do some multiplication, some addition, and some subtraction of fractions. So when I'm multiplying fractions, basically you just multiply top times top, bottom times the bottom. But again, I mentioned this before, you can cancel or reduce fractions before multiplying, making it a simpler problem. So for example, the 10 and 15 here, I might be able to see, okay, I could divide both of those by 5. So divide this by 5, that gives me 2. Divide this by 5, that gives me 3. The 4 and the 8, I could divide both those by 4. 4 divided by 4 is 1. 8 divided by 4 is 2. Notice I have a 2 over 2. You can cancel those. So my answer is 1/3. Right? 1. This cancels completely, right? 1 over 3. Let's go ahead and do the multiplication ones all first. Okay. What about this one? Well, 500 and 100, I can divide both of those by 100. Divide this by 100, that gives you 5. Divide this by 100, that gives you 1. Now multiply top times top, bottom times the bottom. So 30 times 5, that's 150. Over 1, you don't have to put over 1 because anything over 1 is just itself. Anything divided by 1 is just itself. I want you to try number 5 on your own, multiplication. Number 6, here, cross-canceling, I can divide both these by 4. Divide this by 4, that gives you 1. Divide this by 4, that gives you 100. 1 times 100 is 100. Over 1, I don't need to put that. Now let's do the adding and subtracting. Now, in my opinion, adding and subtracting is actually harder than the multiplying because for adding and subtracting, you need to find a common denominator. So for this number 2 here, 3/4 plus 5/6. Well, I need to find a lowest common denominator. Well, what's the lowest common denominator between 4 and 6? Well, it's actually going to be 12. So we could change both the denominators to 12 because 12 is a multiple of 4 and it's also a multiple of 6. So 4 times what gives me 12? 4 times 3 gives me 12. And so I multiply the numerator also by 3. That gives me 9/12. Similarly, 6 times what gives me 12? Well, 6 times 2 gives me 12. So I need to multiply the numerator also by 2. That gives me 10/12. Now we could add the two fractions together because they have the same denominator. Do not add the denominators, just carry it along. The 12ths just get carried along, but you add the numerators. So this would be 19/12. Similarly, for number 4 here, what would be the lowest common denominator? Well, for 8ths and 12ths, what would be their lowest common denominator? So one thing you could always do is just list out their multiples, right? If you're not sure. So for 8, our multiples are 8, 16, 24, 32, 40. For 12, it's 12, 24. Oh, I could stop right there because now I have one they have in common. Okay, so once you see a multiple they have in common, that's your lowest common denominator. In this case, 24ths. And again, whenever you're adding or subtracting, you need a common denominator. Okay. So 8 times what gave me 24? 8 times 3 gave me 24. So I multiply the numerator also by 3. That gives me 21 24ths. These fractions are equal. 7/8 is equal to 21 24ths. For this one, 5/12, I multiply by 2 to get 24. So I multiply the numerator also by 2, gives me 10 24ths. Now that I'm subtracting here, once they have the same denominator, you keep that denominator, do not subtract those, but you do subtract the numerators. So 21 minus 10 is 11, so our answer is 11 24ths. Okay. Notice number 7, this is actually the easiest one. Notice they already have a common denominator. So if they already have a common denominator, all you need to do is add the numerators. 2 plus 1 is 3. So 2 over 4 plus 1 over 4 is 3 over 4. For this one, see if you can do this one on your own. Find a common denominator between fourths and thirds. Change both fractions to have that denominator, and then add them together. You can look at the example we did for number 2 and the example we did for number 4 to help you with number 8 here. Okay, so now we're going to talk about positives and negatives. Okay, so I'll kind of just show you as we go. We're going to talk about multiplying and dividing first. So when it comes to multiplying, when the rules for multiplying and dividing, so I'm going to put multiplication and division rules. So for these rules, basically a negative times a negative will always give you a positive. Same thing with dividing. A negative divided by a negative is positive. Now, if they're different signs, so if you have one positive and one negative, so a negative times a positive, positive times a negative, this will always give you a negative. Now, you don't have to look at which one's bigger or anything like that. So let's go ahead and do these ones, all the multiplying and dividing ones. So negative 2 times negative 3. Again, when you see parentheses up against each other, that means they're multiplied. So negative 2 times negative 3, you just multiply 2 times 3, that's 6. And let's double check to make sure we have the correct sign. So a negative times a negative, okay, that should give us positive. So it's positive 6. What about for this next one? Well, this is the same exact problem, right? If you have a number up against parentheses, that means they're multiplied. So these are just two ways of writing the same thing. Negative 2 times negative 3. A negative times negative is positive 6. Here, negative 3 times negative 2, same thing, 6. What about these ones over here? For number 11 and 12, or just do number 11, a negative times a positive, this will give us a negative. And 4 times 8 is 32. So negative 32. So again, a negative times a positive gives us a negative. Okay. Same idea with dividing. So when you see division, a negative and a positive makes a negative. So 8 divided by negative 4, 8 divided by 4 is 2, but it's going to be negative because a positive and a negative, when multiplying or dividing, gives you a negative. So if they're different signs, that's going to be negative. So this is the same thing here. What about a negative divided by a negative? Well, just like a negative times a negative, that'll give you a positive. So 6 divided by 2 is simply 3. Negative divided by negative makes it positive. 6 divided by 3 is 2. What about these two right here? See if you can do these on your own. So I'm going to let you do 9 and 10 on your own. Here you have a negative 4 times positive 8. Here you have negative 4 times positive 8, same question. Now, the adding and subtracting, in my opinion, that's where it gets much more complicated, because you have to look at whether are the same sign or different signs, and we have to look at also like which do we have more of, okay? But one thing I want to emphasize is that a minus sign, like 5 minus 2, this minus sign is the same as a negative sign, okay? So this is the same as saying 5. This is the same as saying 5 plus negative 2. So these are actually the same problem, okay? So so from here on out, I don't really think about a minus sign as a minus sign. I always just look at it as that's a negative, right? So I look at this as positive 5 and negative 2. What does that make, right? Same as this, right? So a lot of times I'll not even say minus. I'll just say, oh, 5 and negative 2 makes 3. Okay. But the way it kind of works is you could think of it as negatives and positives. They cancel each other when adding or subtracting. So negatives and positives kind of cancel each other, right? And so you could see like the 5 and the negative 2 here, they cancel each other, right? So you're going to have 3 positives remaining. Okay. Essentially, this 5 is 5 positives, and this 2 is 2 negatives, and you're going to be left with 3 positives. They cancel each other, okay? Just like if I had 5 positives, and 2 negatives, notice that you'd be left with 3 positives, okay? What about number 4 here? So I have a negative 2 and a negative 3. So negative 2, that's 2 negatives. And then I've got negative 3, 3 negatives. Okay, are there any positives there to cancel? No. So this is actually negative 5. This is the exact same question, right? 3 negatives and 2 more negatives. That's 5 negatives in total. This is the same question. Okay, so these are all actually the same question, just different ways of writing it. What about this one, number 12 here? This one would have 4 negatives, 1, 2, 3, 4, and 8 positives, 1, 2, 3, 4, 5, 6, 7, 8. So these 4 negatives cancel with 4 of the positives, leaving us with 4 positives. 4 and it's positive. This is the same question. I've got 8 positives and 4 negatives. That's the same as this. So that's the same. Here, same question. 8 positives, 4 negatives. Here's where we get some tricky ones. First, let's look at number 20 here. This is actually the simplest one. I've got 10 negatives and then 6 more negatives. Well, there's no positives there to cancel. This just got a bunch of negatives, right? I've got 16 negatives in total. This one, you might see this quite a bit, actually. If you see this minus negative like that, that actually means like double negative. So when you see a double negative like that, that's the same as saying 10 plus 6, okay? And then it's as simple as that. 10 plus 6 is 16. Okay, that double negative kind of makes it opposite of negative 6. That makes it a plus 6. See if you do number 18 on your own. It's just like number 19. So I'm going to ask you to do that one on your own. Number 17 here, we have a negative in front of this parentheses. Now, what that does is this negative goes to everything in the parentheses. So that's going to make it a negative 5. And then negative 2 makes that a positive 2. So it essentially changes the sign of everything in the parentheses. So here I've got 5 negatives, 1, 2, 3, 4, 5, and then 2 positives. What you're left with is 3 negatives, just like that. Okay. All right. Let's go over this last set of problems. What is the greatest common factor between 10 and 15? So what's the biggest number that divides both 10 and 15? Well, that's 5. Use the greatest common factor, which we just found, to reduce the fraction 10 over 15. So what can this greatest common factor be used for? It can be used for reducing fractions. So if we have a fraction and I see, oh, they're both divisible by 5, what we can do is divide both top and bottom by that common factor. So this would be 10 divided by 5 is 2, 15 divided by 5 is 3, and so 2/3 is our answer. Now, when I see this multiplication here, I might say, okay, well, I can divide cross cancel, right? So I can divide this by 5, that gives me 1. Divide this by 5, that gives me 2. Similarly here, I can divide this by 5 to get 3, and I can divide this by 5 to get 1. So I can divide both these by the same thing, divide both these by the same thing. Now, when I multiply a fraction, multiply top times top, bottom times the bottom, and there you go, 1/6. What is the lowest common denominator for 10 and 15? I think we've covered that one already. It's 30, right? 30. And we need that lowest common denominator if we want to add fractions. So in this case, if I want to add these, I would change both their denominators to 30. And this goes for adding or subtracting fractions. You need a lowest common denominator. So 10 times what gives me 30? Well, 10 times 3 gives me 30. So I multiply the top also by 3. So 9/30 is what 3 over 10 is equal to 9 over 30. Here, to change 5/15 into 30ths, I multiply the 15 times 2. So I multiply the numerator also by 2. So that'll give me 10/30ths. Now that they have the same denominator, we could add them together easily. 9 plus 10 is 19. So it'll be 19/30ths. What's the greatest common factor between 25, 50, and 75? Well, in this case, it's 25. 25 divides 25, 25 divides 50, 25 divides 75. What is the lowest common denominator for these group? Well, that's actually going to be, let's look at our 75s, for example. So 75 times 1 is 75, times 2 is 150, times 3 is 225, times 4 is 300. Okay. And every multiple of 75 is also a multiple of 25. So we just need to look at what 50 goes into. Well, that goes into 150. So they all go into 150. And you can always check that as well. Now, when you multiply negatives, again, a negative times a negative makes a positive, right? So -4 times -4 is positive 16. So then we do positive 16 times -4. Okay, positive 16 times -4. This is a positive times a negative. So that's going to give us a negative 64. Negative 64. Here, -4 times -4 is positive 16. Negative times negative is positive. And I can multiply these together as well. So that makes another positive 16. 16 times 16, I think that's 256. Yeah. What do you get when you combine the following numbers? So -4, -4, -4, -4, -4, -4, -4. So that's 1, 2, 3, 4 negatives. 1, 2, 3, 4 more. 1, 2, 3, 4 more. 1, 2, 3, 4 more. So that makes a total of 16 negatives. Okay. -16. Okay. And I think that's it for the guided practice. All right. Yep. So that's it for the guided practice. I hope you're able to follow along. Let me stop sharing my screen here. Hope you're able to follow along, and I hope that all made sense. I know that took a while, but if you're able to get that all done, then you should be good to go. Especially, and then you could try a lot of the book work on your own. If you have any additional questions, you could always email me. My email is ttrigg@ofy.org. All right. Well, with that, good luck and take care.